Yeah, what's up guys? Today I'm gonna show you how solar cells work. Before we start, I want to explain some technical terms first. The first one is free hole. Let's look at this normal helium atom. Now an electron left and it becomes a helium with one positive charge. And this kind of positive charge, we call it free hole. The second one is intrinsic semiconductor. It simply means a semiconductor without any things except silicon. The third one is doping. Doping is the process that adds tiny amount of impurities to intrinsic semiconductor. And the last one is carrier. In this introduction, carrier refers to free holes and electrons. There are two types of semiconductor. When a semiconductor contains free holes, it is called p-type, and when it contains free electrons, it is known as n-type. In order to make a semiconductor which contains free holes p-type, you have to add solid elements with 3 valence electrons, such as boron or gallium, to an intrinsic semiconductor. To make a semiconductor which contains electrons n-type, you have to add solid elements with 5 valence electrons, such as antimony or arsenic, to an intrinsic semiconductor instead. To explain how adding impurities makes a free hole or an electron, let's take a look at this picture. As we know, the materials consist of intrinsic semiconductor is silicon. Silicon has 4 valence electrons. So you just need to add 5 valence electrons to create an electron, or add 3 valence electrons to create a free hole due to the octet rule. The main structure of a solar cell is made of both p-type and n-type semiconductor. To make this semiconductor become a solar cell, you have to join them together. The interface between two types of semiconductor is called p-n junction, and inside the p-n junction, there's an area called depletion region. The p-n junction is the most important part of a solar cell because it is the place where electrons and free holes created. Because of the concentration difference between electrons and free holes, it will form an electric field from n-type to p-type semiconductor. When light strikes the n-type region and it penetrates and reaches up to the depletion region, this photon energy is sufficient to generate electron-hole pairs in the depletion region. The electric field drives the electrons and free holes out of the depletion region. After leaving the depletion region, electrons move upwards to the n-type area and free holes move downwards to the p-type area. When the concentration of electrons in the n-type area and free holes in the p-type area become so high that a potential difference will develop between them. So we got a potential difference. Now we just have to connect the two sides of the solar cell with a wire, and boom, you got a current. But one thing to remember is that solar cells generate direct current instead of alternating current. If you want to turn direct current into alternating current, you need a device called power inverter. After understanding the working process of a solar cell, let's look further into the structure of a solar cell. As you can see, the n-type area is much thinner than the p-type area. This is to increase the performance of the cell. Because the thinner the upper part of the cell is, more light can penetrate into the depletion region. And of course, more light means more photon energy, and the solar cell generates more power. That's the end of my video. Thanks for watching.